Alright, so our first equation that we use lots and lots is V equals IR. We only use the P equals IV if we're talking about power. We have two equations for finding total resistance. This first one, where they just add up, is how we find total resistance or equivalent resistance in a series circuit. This part right here, the 1 over R plus 1 over R, etc., is how you find total resistance or equivalent resistance in a parallel circuit. Defining each variable, giving the correct units. So V stands for voltage, and we measure voltage in volts, or V. I stands for current, and we measure current in amps, or capital A. R stands for resistance, and we measure resistance in ohms, or this funky horseshoe looking at, I wouldn't even call it, no. Alright, if we want a lot of current going through a circuit, do we want a big voltage or small voltage? Big resistance or small resistance? So I'm going to take my V equals IR, and I'm going to rearrange for I, so I'm going to divide the R over like this. So I get that I, or current, is just voltage divided by resistance. If I want this number to be as big as possible, then you want big number on top, because you want to multiply by big numbers, but you don't want to divide by big numbers, because that would make it small. You want to divide by small numbers. You want a big voltage, and you want a small resistance. So that's the equation way of thinking through this. The other way is think, okay, well, current is how much charge is flowing through a circuit. If I have a big voltage, then that's going to get more current flowing, because voltage is the reason it flows in the first place. And then resistance is how much it's stopping or slowing or making it harder for that current to get through. So if I want lots of current getting through, I don't want a lot of resistance. I want very little resistance so it's easy to get through. Alright, we have two different sets of rules for our two different circuits. So series circuit, the current, or I, is the same everywhere. For parallel, it's your voltage that is the same everywhere. And then for a series, your voltages are going to add up to the total voltage. And for parallel, your currents are going to add up to the total current, like this. And then also the R total, but we've already wrote that right there, so we don't need to write that down. Alright, first circuit, is this series or parallel? There is one path for the current to follow, so that is a series circuit. We want to find the current through the 5 ohm resistor, so I'm just going to label what I have. This is V total. I'm going to call this R1 and R2. I want the current through the 5 ohm resistor, so it's very tempting to use V equals IR with the 5 ohm resistor. But if I were to plug in V equals IR, which we definitely want to do, the only voltage that I know is the total voltage. So if I'm using total voltage, these all have to match, so I have to use R total. So for a series circuit, R total is easy. You just add up the individual resistances. That's 4 plus 5, so that gives me R total is 9 ohms. So now I'm able to plug in. Total voltage is 9. Current's what I'm looking for. R total is 9. Divide over, you get total current is 1 amp. And then you might be saying, well, I didn't ask for total current, I asked for the current through the 5 ohm, but total current is the same in a series circuit. So this would have 1 amp, this one would have 1 amp, and the total would be 1 amp. So they're all the same. It doesn't matter which I find for series, because they're all 1 amp. And now we're finding the voltage drop across the 4 ohm resistor, so I'm going to use V equals IR. Specifically, I'm looking for the first voltage drop. So I have to use the first current, which is all the same, 1, and the first resistance, 4. So that gives me a voltage drop of 4 volts, which is my answer. Circuit to the right is a parallel circuit because current is going to come up right here. It's going to split between these two branches, so this is a parallel. To find total resistance, I have to do 1 over R total equals 1 over R1, which is 2, plus 1 over the other resistance, 6. So then what this looks like in your calculator, we would do 1 over 2 plus 1 over 6, and then that's what 1 over R total equals, 0.667, so then you have to do 1 over that, and that's going to give me 1.5. So total resistance, R total, is 1.5 ohms. What is the total current? Well, we know total voltage, right? This is V total, this was like our R1, this is R2. So So we can plug in V equals IR, looking for total current, so use total voltage and total resistance. In this case, finding current, I have to find I total because I is not the same because this is a parallel. V is the same. So total voltage is 10, total current is what we're looking for. Our total we just found is 1.5. Divide over, and that's going to give us, I total is 6.67 amps. Voltage drop across the 2 ohm resistor. Actually, a super easy question. V1 is going to be 10 volts because voltage is the same for a parallel. You don't need to find it. Current through the 2 ohm resistor. So I'm going to use V equals IR. I'm looking specifically for I1, so I'll use R1 and V1. V1 is just 10 volts, I1 is what we're looking for, R1 is just 2, so the current through the first resistor is 5 amps. So what we have is right here, you've got 6.67 amps, you've got 5 amps right here. If I asked for the next one, you could use V equals IR, or you could just subtract from the total. This would be 1.67, but I didn't need it. Actually, I'm going to need it in a second, because it says what is the power dissipated in the 6 ohms, so I'm looking for P2. Well, P equals IV. If I'm looking for power 2, I just use I2 and V2. This is a parallel circuit, so I already know the voltage is going to be 10 volts. What I don't know is the current yet. So I can use V equals IR to find I2. Voltage drop of 2 is 10. Resistance of 2 is 6. Divide over, that's going to give me 1.6. Oops. Let me double check. Yes, 1.67. And then now I can say, oh, okay, I know I2, it's 1.67 times V2, which was 10. Plug in, that's going to give me a power drop of 16.67 watts, which is your answer. Why we use this current 1.6 instead of the 5 or the 6.67 is because I'm specifically looking for the power in the second resistor. If I wanted the power in the first resistor, I would have used the 5. If I wanted the total power, I would have used the total current. Next one is a series circuit. Total resistance, you just add up. So 4 plus 8 is going to give me a total resistance of 12. Total current, you plug in, V equals IR. Total voltage is 6. Looking for I total, and total resistance is 12. When we're dividing over, we're going to divide the 12 over to cross off to get 12. I'll just show 12 by itself, so you should be getting I total is 0.5 amps. Voltage drop across the first one, so I'm going to call this, the 8 ohm. I'm going to call it R1 and R2. It doesn't matter what you label it as long as you're consistent. So that means we're looking for V2, so I2, R2. Well, I already know because I is the same everywhere, so it's just 0.5 times 8, which is going to give me 4 volts for part D. Now part E is finding the power in the first one, so P1 equals I1 V1. Well, we already know I1, it's just the 0.5 amps, so that means I need to know what my V1 is. That is not 6 volts, that's the total voltage. And it's not, oh, I just wrote right here, that was V2. It's not the 4 volts because that's the voltage associated with the 8 ohm resistor, so I'm going to have to find V1 equals I1 R1. No current, and I know that the resistance is just 4 for this one, so that gives me a voltage drop of 2 volts. So then you plug in 0.5 times the voltage drop is going to give me 1 watt for the power in that 4 ohm resistor. If I had done this voltage, you can do 0.5 times this, it's going to give me 2 watts. That would just be the power associated with this resistor. If you did this times the 6 volts, that would be the power associated with the total. Just not what I asked. Alright, number 4, voltage across the 5 ohms. We're going to plug into V equals IR. In order to find, let's call this R1 and R2, I'm looking for the voltage drop, the first voltage drop. I know R1 is just 5. That means I need to find I1. Now, I don't have I1 right now, but I do have this voltage of the battery, which is your total voltage. So I can use V equals IR, use total voltage and total resistance to get the total current. So 20 equals I total. Total resistance would be the 5 plus the 15, which is 20. So that's going to give me a total current of 1 amp. And then current is the same everywhere. So this is going to be all my current. So I can plug it in for the I1. That gives me that V1 is 1 times 5, which is just 5 volts. Equivalent resistance of this circuit, so that's just asking for our total. So we're going to use the 1/4 plus 1/6 because we are talking about a parallel circuit. We have the 1/4 plus 1/6, hit enter, and then don't forget to do 1 over that. So that's going to give me that our total is equal to 2.4 ohms. Current through the 6 ohm resistor, so I'm of course looking for current I. I'm going to call this R1 and R2. I'm specifically looking for I2, and then the current through the 4 ohm, I'm specifically looking for I1. So I'm going to plug in V1 equals I1R, or sorry, we're on 2 right now. V2 equals I2R2. Well, this is my total voltage, but voltage is the same everywhere, so it's also V1 and V2 because this is parallel. So I can say 24 equals I2, and then R2 is just 6. Divide over, you get I2 is equal to 4 amps. Very, very similar for the next one. I'm looking for the current through the first branch. So V1 equals I1R1. V1 is still 24 because all the voltages are the same. I1 is what I'm looking for. R1 is just 4. Divide over, I get I1 is 6 amps. And then if you really wanted to check, this would give me a total. So this is saying 6 amps right here. This is saying 4 amps. Makes sense, this gets a little bit more current because it's a little less resistance, a little easier to get through. That would give a total of 10 amps, which makes sense with R total because I total times R total would give me the right voltage total. Voltage drop across the 4 ohm resistor is just 24 volts. You already know that. Voltage is the same in a parallel circuit. Alright, another parallel. We want the current measured by this ammeter. So this, I'm of course looking for current I. It's not just in the first branch, it's not just in the second branch, it's when the currents are together, so that's going to be the total current. So I think the easiest way to do this is find R total. So 1 over R total equals 1/5 plus 1/5. So in your calculator that would be 1/5 plus 1/5, and then don't forget to do 1 over that to get the R total by itself. So R total is 2.5 ohms. And then V equals IR. Finding total current means use total resistance, total voltage. Total voltage is just 1.5. I total is what I'm looking for. Total resistance is 2.5. So I'm going to divide the 2.5 over like this, and that's going to get me 0.6. So total current is 0.6 amps. And the voltage drop across each branch is going to be 1.5 volts each because V is the same for a parallel circuit. The next part is saying if you were to add a third branch with a switch instead of resistor. So let's say we've got a switch right here. What would happen when the switch is closed? If the switch is closed, then all the current would flow through the third branch instead. So none of the current would go to these 2 branches. It would all just go in the third branch once we close this because it's an easier path. Because there's now an easier path to get to the other side of the battery. So it's going to choose the easier path every time. Why would it go through these resistors, which are hard to get through, when it could just go through the switch? 7, finding the missing resistance. So I've got R1 looking for R2, no R3, and this is the total voltage. So V total equals I total R total. This right here is my current. I'm not going to call it any specific current because current is the same for series. So it's I total, I1, I2, I3, all of the above. Now I can plug in. Total voltage is 120. Total current is just the 2 amps. Divide over. That's going to give me that my total resistance is 60 ohms. Now it's tempting to just circle this and keep going, but that's not what I asked for. That's the total resistance because I use total voltage. So you need to think, okay, if this is 20, this is 30, that right here is 50 volts. If I have a total resistance of, 50 ohms. If I have a total resistance of 60, that means this must be 10 ohms. So your missing resistance, R2, is 10 ohms. That would be your answer. Number 8. This is a parallel circuit. Voltage is the same, so that's my total voltage. It's also V1 and V2. This current right here is before the current splits up into branches, so that's your total current, so 3 amps. R1 is 12 volts, so I can use V1 equals I1 R1 because V1 is still just 12, voltage is the same. R1 is 12, so I can divide over. I can get that the current right here is 1 amp. And then I don't know the resistance, so I can't plug into V equals IR, but I do know that my individual currents add up to the total. So I have 3 amps right here, and 1 amp goes this way. That means that what's left is 2 amps right here. So then I would plug in V2 equals I2R2. Voltage drop 2 is 12. Current 2 is 2 amps. Divide over, that gives me an R2 of 6. To find the equivalent resistance, that just means R total. 2 ways you can do this. You can use V total equals I total R total. Total voltage is 12. Total current is 3. Divide over, you're going to get 4. Or you can use the equation for R total for parallel. First resistance is 12, and then the second resistance we just found is 6. And then don't forget to 1 over that. Either way, you're going to get 4. It doesn't matter. All right, next one is a series circuit. So I have R1, R2, and then this right here is the current. Current is the same in series, so that's I1, I2, I3, I total. Actually, there's not an I3, so just I1, I2, I total. So V1, I would just use I1, R1, I1 being 5 times this resistance. That's going to give me 25 volts. V2 equals I2, R2. I2 being 5 amps, R2 being 15, that's going to give me 75. And then you could just add up, because you know your voltages add up to the 100 volts, or you could use V total equals I total, R total, total current being 5, total resistance just being 20. Either way, you're going to get 100. Alright, this is again a series. This is my V total, this is V3, this right here is V2. So first let's find current, because current is the same. That's going to help me find lots of things. So I would find I3 first, because I actually have V and R for that one. So V equals IR. V3 is 20 volts, and R3 is 10. So when you divide over, that gives me a current of 2 amps. And then current is the same, so all of these, ooh, that's not an I. So all of the I's are 2 amps. Next is asking for V1. Well, we know our voltages add up to the total voltage. So if my total voltage is 40 volts and then these two drop 30, that means this one has a voltage drop V1 of 10. So it should be a 10 volt. And then now I can find my missing resistances by using V equals IR. So V1 equals I1 R1. We just said V1 is 10. I is going to be 2 for all of them. Divide over, that gets me a resistance of 5. And then here, same thing, V2 equals I2 R2. V2 is also 10. Current 2 is still 2. And then that means this is 5. And then you can always double check if this is 5, 5, and 10. That's a total resistance of 20 times the total current of 2 would give me a total voltage of 40. So that at least checks out. Parallel circuit, so this is my V2, but it's also my V total is, 30 volts, because voltage is the same, and V1, because voltage is the same, so these are all 30 volts. I can find this current really easily, because I have both voltage and resistance, so 30 equals I2 15. Divide over, you get 2 amps right here, that is I2. Right here, I can use V1 equals I1 R1. V1 is 30. I1 is what I'm looking for. R1 is 10. That gives me 3 amps. And that means I have a total current of 5 amps right here. And then to find equivalent resistance or total resistance, you can use V total, I total, R total. V total being 30. I total is 5, what we just found. R total, divide over, you get 6. Or you can do 1 over 10 plus 1 over 15 and 1 over that. That'll still give you 6. It doesn't matter. Right, here we have 6 volts, so this is my V total, it's also my V1 and my V2, so this is going to be 6 and 6. Finding my missing resistances, I can just use V equals IR. V1 is going to be 6, I1 it has right here is 2 amps, so you can divide over, you get 3. And then I2 is just 1 amp, so I'm going to use V equals IR with the second branch. V2 is going to be 6 volts, I2 is just 1 amp, and then that means R2 is 6 ohms. Total current would just be 3 amps because it's the two of them together, and then your total resistance, we just said this one was 3 and this one is 6, so 1 over R total equals 1 over 3 plus 1 over 6. Put this in your calculator, hit enter, 1 over that would get me R total is than 2. Also, you can use V total and I total. That works as well. Number 9, at first, switch S is closed. So right now it's closed. There's current going through all of the bulbs. When this switch is opened, what bulbs go out? Well, bulb W is going to go out because current can still definitely go through this loop. So bulb X is still going strong. If I open the switch, I can still get through here. The only thing that's not able to go through is bulb W. So current's going through all the other ones, only W goes out. Equivalent resistance, so this one you would just straight add, they share the same current, it's 16. Same here, you just straight add, I think you get 10. Yeah. You add up, you get a total resistance of 10. The other 3 have all of their resistances in parallel, so I would have to do the 1 over R total equals 1 over 4 plus 1 over 4 plus 1 over 4, and then 1 over that, and that's going to give me R total is 1.33. Here, 1 over R total is 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. Hit enter, 1 over that gives me R total of 0.48. And then here it's just 1 over R total is 1 over 8 plus 1 over 8. That gives me a total resistance of 4 ohms. So this one is definitely the least equivalent resistance. This one is the most. This would be like second most. This one is second least. And then this is the guy in the middle. Alright, combination circuits, first finding equivalent resistance. So for these, we can't just straight add them all up, but it's also not all 1 over plus 1 over. It's different. Some are in series with each other, some are in parallel. So when we look at this one, I would start with these two. These two split current between them, so they're going to be in parallel. So you do 1 over R is 1 over 12 plus 1 over 6. Go to your calculator. 1 over that. That's going to give me an R of 4. So I'm going to redraw this. I've got a 9 ohm, and instead of the 12 and the 6 in parallel, that's the same as just a 4 ohm right here. And then I haven't changed anything else. These are still here. Now it's a 9, 4, and 5 in series with each other, so I can just add these up, and that's going to give me an R total of 18 ohms. Total current of the circuit, that's easy once you know R total. V equals IR. Total voltage is the 24. Looking for I total, have to use R total so that all of my subscripts match. Divide over, that's going to give me a total current of 1.33 amps. Now it's asking for the voltage drop across the 9 ohm resistor. That's actually pretty easy because we know the total current, and right here, this is before the current split, so this is the total current right here. So if I'm going to call it like V1, I1, R1, this current is I1, so 1.33 times the 9 is going to give me a voltage drop of 12 volts. And if you didn't keep it in your calculator and you're getting like 11 point something, it's totally fine. Voltage drop across the 5 ohm resistor, so we're again using V equals IR. I know the resistance is going to be 5. What current is it? Well, actually, so the current splits here, so these do not each have 1.33. It's different. It gets kind of complicated to find those. But these are going to come back together, so when they come back together, this is now the total current again. This one does have 1.33. So you do 1.33 times 5, and that's going to give me a voltage drop of like 6.67, I think. Right, number 2, finding the current through the 10 ohm resistor. Well, the current through the 10 ohm is just the total current, so we're going to use V total equals I total R total, which means we need to find total resistance. So I'm going to do these two. They're in parallel, so that would be 1 over R is 1 over 33 plus 1 over 66. Replace those, that just becomes 22. And then you have a 22 and a 10 ohms, that gives you R total is just 32. And now we can plug in. Total voltage is 12, I total, R total is 32. Divide over and you get 0.375, so this one. Number 10, what type of circuit? This is a series circuit. To find the current through the, I'm going to call this R2 and R1, this is V total. Well, to find current, I'm going to use V equals IR, and the only voltage I have is total voltage, so I'm going to plug in 12 I total. I have to use R total, which is 90 when I add them together. divide over, I get my total current, it's a decimal for sure, 0.133 amps. Why I found I total instead of dividing the 60 is because I didn't know what the voltage associated with the 60 is. If I'm going to use 12 volts, the total voltage, I better use R total. And it's okay that I find I total because I is the same everywhere for a series circuit. Voltage drop across the second resistor, so V equals IR. I2 we just found because all the currents are the same, and then just use the R2 that was given. That gives me a voltage drop of 8 volts, or if you didn't keep it in your calculator, it's like 7.898, that's fine. Find the current that the ammeter shown would read. Well, that's the total current because that is back when all the branches are back together again. So I would find R total. 1 over R total is 1 over 5 plus 1 over 5 plus 1 over 5. Make sure and do 1 over that, and that's going to give me a total resistance of 1.67. And then I'm going to use V total equals I total R total. Total voltage is 5 volts. Looking for total current. Total resistance we just found is 1.67. Divide over, and that will give me a total current of 3 amps. Which makes sense because each of these would then have 1 amp, 1 amp, and 1 amp because they have a voltage drop of 5 and a resistance of 5, so 1 amp for each, and that would add up to a total current of 3 amps here and 3 amps in this section when they're all back together again. Would the ammeter shown read more or less than 3 5-ohm resistors in series? So let's say I still have a 5 volt, I still got my ammeter right here, but what if instead of 3 5 ohms in parallel, I have them in series, like this. 5, 5, 5. If you were to find this current right here, V total equals I total R total, same voltage, new total resistance. My total resistance, instead of being the 1.67, is just going to be 5, 5, and 5, which is 15. That's going to divide over and give me a total current of 0.33 amps, which is definitely less than 3 amps. So the ammeter shown would read more than the 3 in series. The one in series would be less. The parallel would read more because it has a smaller R total, more current. This has a greater R total, so less current. Current through the first resistor, so V equals IR. I'm going to use total current total resistance because the only voltage I have is V total. 1.5 equals I total. Total resistance is 10, so total current is 0.15 amps. Voltage across the second resistor, so V2 equals I2 R2. I2 is going to be the same as the total current because current is the same multiplied by the resistance 2. That gives me a voltage drop of 0.75 volts. Equivalent resistance, the current through each branch, and the missing resistance. So this right here is my total current. It's before it splits up. I know my voltage. This is my V total, my V1, and my V2. So let's find what I1 would be. V1 equals I1 R1. V1 is just going to be 30 volts. I1 is what I'm looking for, 20 ohms. That gives me a current of 1.5. Yeah, 1.5 amps. So if I have a total current of 2 amps and I have 1.5 in this one, that means what's left is 0.5 in this one. So I2 is going to be 0.5 amps because they have to add up to a total of 2. And then you can use V2 equals I2 R2. I2 is 0.5, looking for R2. V2 is just 30. Divide over, R2 would then be 60. That was the main thing I'm asking for, but I also asked for equivalent resistance. So equivalent resistance is easy. If you know total voltage and total current, you can just use V total equals I total R total. Total voltage is 30, I total is 2, so that would give me total resistance of 15. Or you could have done 1 over 20 plus 1 over 16, 1 over that to get the R total of 15. Which is the same resistance as the circuit shown. Well, this is 6 ohms, yeah. 1 over R total equals 1 over 6 plus 1 over 6 plus 1 over 6. That gives me a total resistance of 2. Here, they just add up, obviously. That would give me a total resistance of 14. Here, this is a total resistance of 2. 1 over R is 1 over 12 plus 1 over 12. This would give me a total resistance of 6. 1 over 2 plus 1 over 4 plus 1 over 6 is 1 over R here, so that would give me a total resistance of 1.09. So the one that matches the original is just B. Assuming they all have the same voltage battery, which circuit would have the most current? So, most total current. So let's think about V equals IR. The one that has the most current, if they have the same voltage, is the one that has the least R total. So let's find R total for each of them. This one has R total of 4. This one has R total of 8. They're in series. It's easy to find it. For A, you would have to do 1 over 2 plus 1 over 2 to get R total. And that would just give you 1. And then here, 1 over R total is 1 over 2 plus 1 over 2. I'm going to run out of room. Plus 1 over 2. And then when you add that up together and 1 over that actually gives you R total of 0.5. So the one with the most current, total current going through it, is the one with the least total resistance, which is C. Which is weird because it has lots of resistors, but the more resistors you put in parallel, then the lower the current, the total current is going to get. Or sorry, but that's true, but the more resistors you put in parallel is the more higher R total, which is kind of counterintuitive, but you're actually adding fractions. Current through the 20 ohm, wow, I put a lot of these on there. V total equals I total, R total. Total voltage is the source or the battery, 120. I'm looking for I. Total resistance is 30. Divide over, that's going to give you 4 amps. Combination circuit. So here we are just combining just resistors at a time. Are we adding them, or are we adding the inverse? Depends on if they share the same current. Are they in series, or do they split current? They're in parallel. So these two obviously share a current. They're right next to each other. Nothing splitting between them. So this would just become 100 ohms. These two are in parallel, so we'd have to do the 1 over 37, 1 over 45 to get what that resistance right here is. So that becomes 20.3. So I'm going to redraw. We've got 80 right here, we've got 100 right here, we've got 20.3, and we've got 75. Like this, and this is 80. So first you need to combine these. 20.5 plus 75, that just becomes 95.3. So I'm going to replace this with 95.3. And then now these two are in parallel, so 1 over 100 plus 1 over 95.3. And that's going to give me R is 44.5. And now you have an 80 and 44.5 round like this. So now you can just straight add these two, and that's going to give you your total resistance of 124.5 ohms. Alright, here, these two in parallel, 1 over 24 plus 1 over 8, 1 over that, that's going to be replaced with just 6. Same here, these two split current, so they're in parallel, 1 over 10 plus 1 over 15, 1 over that is just going to give me 6 again. So I've got 3, 6, 6, 6, like this, and then a 3 ohm, and a 5 ohm right here. So I'm just going to replace the 3 and the 6, that's just going to become 9 right here. Ignore this now. The 6 and the 6, that's just become a 12 ohm right here, and then I can ignore that. The 9 and the 12 are in parallel with each other, so I'll have to do the 1 over 9 plus 1 over 12 to get what those two together are. So that is going to become 5.14. I'll just redraw it over here. So now on top is 5.14. I still have the 5 ohm right here, connected to a battery, and then a 3 ohm right here. Now they're all in series, so I add them all up, and that's going to give me a total resistance of 13.14 ohms. 9 is the current through the ammeter shown more or less when the switch is closed compared to when it is open. So right now, the current is really easy to find. Right now, the current, if it's open, is just this one loop. Has a voltage of 24 and a resistance of 12, so right now the current is 2 amps. Now when you close the circuit, now the current is going to split between these two, so it's going to have like a second resistor in parallel, and we know that when we add in resistors in parallel, that makes the total resistance less, and that would increase the total current. Or if you're like, what? You could just actually do the calculations. Now you can find I total when it is closed. So this is for when it was open. That was real easy because it was 1 voltage, 1 resistance. When it's closed, our total is just going to be 1 over 4 plus 1 over 12. That gives me a total resistance of 3 ohms. Yeah. So then you would use V total equals I total, R total. Total voltage 24. I total is what I'm looking for. R total is 3. And when it's closed, you'd have a total current of 8 amps, which is definitely more than 2 amps. So when you close it, the current is going to show more, or the ammeter is going to show more current. What is the missing resistance? So I have V total, I've got a current, I've got, that can be I1 or I2 or I3 or I total, so I'll just call it I. And I'm finding missing resistance, so let's plug in V equals IR. V total is 12, I total is 1.5. Divide over, that gives me that the total resistance in the circuit is 8 ohms. Now, right here, 4 and 2, I already have 6 ohms, which means that the missing resistance is 2 right here. So the missing resistance is 2. Careful not to box the total resistance because I want what's missing. If you were to draw a wire from X to Y, what would the new current through the circuit be? Well, if I put a wire right here, current is going to choose the easier path around these two, so the only resistance that it would go through is the 2 ohm right here. So basically, you're redrawing the circuit with 12 volts and just a single resistor, 2 ohms. So then V equals IR, total voltage is still 12 volts, looking for your new current. Your total resistance now is just this resistor right here, too. So that would be a total current of 6 amps. If A was unscrewed, what bulbs remain lit? If you take out A, then current can still go around this way, so B and C would still be lit. If C was unscrewed, now you can't go through this loop, but you still can go through this loop, so the only one that would be lit if C was unscrewed is A. B, it might be tempting to be like, oh, the current would go until it hits this like hole, but if there's any hole in that loop, then there'll be no current in that loop. So no current would flow in the first one, it would just flow in the closed loop through A. If A is unscrewed, what bulbs are lit? If you take out A, then no current is going to get it through at all, so this would be none. If B is unscrewed, so you put a hole right here, you still can have current going through this loop, so A and B would remain lit. So if you want the bulb on and the brightest it could possibly be, how would you want switch 1 and 2 open or closed? So let's first start with, do you want the bulb on or not? If you want the bulb on, then switch 2, so switch 2 must be open, because if you were to close it, current would then go through the easier path and it would skip the bulb. We don't want that to happen. We want it to go through the bulb, so we do not want to give it an easier path around. Now we want it to be bright as possible, which is now what we're talking about with switch 1. Because switch 1 isn't going to determine if this one is on or off, but it will change the current through the system, or through the circuit. If you close this, then current, and keep this open, then the path current flows is going to be around this resistor, but still through the bulb. And the reason we want it to go around this resistor is because then there's less resistance in the circuit, so you have more current flow. So switch 1, you actually want to be closed because you want to skip the resistor, so there's less R total and more total current, because more current through this bulb is going to make it go shine brighter. Equivalent resistance, so these two are in parallel. You do 1 over 40 plus 1 over 60 and 1 over that, and that's going to replace it with 24. These three are all in parallel. 1 over 15 plus 1 over 15 plus 1 over 15, 1 over that is going to give me 5. And then now you have 10, 5, 6, 24, and then a battery somewhere in here. So you would just straight add them up now. So that's going to give me an R total of 45 ohms. The equivalent resistance of all of this is 14, so if this is 8, that means that this right here has an R total of 6. So 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. This is a challenge, you don't have to do this, but in case. So that would be 1 over 6 is 1 over, I don't know what R1 is, so that's a 1 and 2, plus 1 over the 20 plus 1 over the 60. So you can add these two, subtract over and 1 over that, and you're going to get 10. Here, the current through resistor 1. So how did I do this? Oh, these are all 3 in parallel with each other. This one has 3 times the resistance. This one has 6 times the resistance of the first one. So this is going to get most of the current, and then some here, and this is going to get the least. What's actually going to happen, so I replace this one, you get like 11 and 22, like this, if you replace these two in parallel. So if you have 6 amps coming in here, this is going to get twice as much current as this one, so that means you get 4 amps right here and 2 amps here. So then the 11 ohm, or the 1 resistor, is going to get 4 amps. Study hard. Do the whiteboard practice as well.